Section 13.5, Chapter 6.3 in our textbooks, Trigonometric functions of any angle. Our objective is students will successfully use reference angles to evaluate trigonometric functions. Suppose we are given an angle on the unit circle. Notice that angle intersects the circle at a certain point. Let's call that point XY. We are going to draw a perpendicular line straight down from that point, and now we have a right triangle. We need to think about the hypotenuse, we'll call it R. We need to think about what the length of this side, this bottom side of the right triangle, is going to be called. Think about your ordered pair and think about how far over you have to go to get up to the ordered pair. So that bottom side of the triangle is length X. Now, from the end of that side, we need to move up so we get the length of the other side, and let's call that Y. Using SOHCAHTOA, we can now find our 6 trig ratios. Sine is opposite over hypotenuse. Our opposite in our triangle is Y. Our hypotenuse is R, so sine is Y over R. Cosine is adjacent over hypotenuse. Our adjacent is X. Our hypotenuse is R. Tangent is opposite over adjacent. Our opposite is Y. Our adjacent is X. So tangent is Y over X. Cosecant is the reciprocal of sine. So we have R over Y. Secant is the reciprocal of cosine. So we have R over X. Cotangent is the reciprocal of tangent. So we have X over Y for that. Okay, it's time to finish filling out our trig chart of our most common angles. So let's suppose we have an angle of 0 degrees on a unit circle, so the radius is 1. That angle intersects the circle at this point, and the ordered pairs for that point are 1, 0. Now we're ready to fill out sine, cosine, and tangent of 0 degrees using our sine theta equals y over r, cosine theta equals x over r, tangent theta equals y over x. So sine is y over r. Our y value of our ordered pair is 0. Our r of the circle is 1. So 0 over 1 simplifies to 0. Cosine of 0 degrees is going to be x over r. Our x value for our point is 1. Our r for the circle is 1. So 1 over 1 simplifies to 1. Tangent is going to be y over x. Our y value is 0. Our x value is 1. So tangent is 0. For our 90-degree angle, okay, see our second circle. It intersects the circle at that point. The ordered pairs for that point are 0, 1. So now we're ready for sine of 90 degrees. Sine of 90 degrees is y over r. Our y value of our point is 1. Our r value is 1, because again it's still a unit circle. So 1 over 1 is 1. Cosine of 90 degrees is going to be x over r. Our x value is 0. R is 1. So 0 over 1 is 0. Tangent of 90 degrees is y over x. Our y value is 1. Our x value is 0. Remember, we are not allowed to divide by 0. Anything divided by 0 is called undefined. Okay, so to do this with any point in general, so the example is let negative 2, 3 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. So first, draw your circle. Sketch where your point would go. So we go negative 2, so 2 to the left, and then we're going to go up 3. And that is where our angle will intersect the circle. So we have our right triangle and we need our radius of the circle. So in order to find that radius, we need to do Pythagorean theorem. And your radius is always your hypotenuse of your right angle. So r squared equals negative 2 squared plus 3 squared, or you can just do r equals the square root of negative 2 squared plus 3 squared. Negative 2 squared is 4, 3 squared is 9, so r is equal to the square root of 4 plus 9, which equals the square root of 13. Okay, now that we have that, draw that on your right triangle, and it's time for sine, cosine, and tangent. Sine of our angle, sine is y over r, so 3 over root 13. Rationalize that denominator because you cannot leave square roots in the denominator. You're going to multiply top and bottom by square root of 13, and you get 3 root 13 over 13. Cosine of theta is going to be x over r. X is negative 2, r is root 13, so we get negative 2 square root of 13 over 13 once we rationalize the denominator. Tangent is going to be y over x. Y is 3, x is negative 2. And there you have your 3 trig ratios. Okay, another little fact that we're going to use is the signs for each quadrant that an angle terminates in. Okay. This seems a little choppy because we are jumping around a bit, but at the end all the pieces are going to come together, so you just have to patiently wait, learn the little pieces separately so we can combine them all together at the end. Okay. So we are looking at our chart that has 1 through 4 quadrants, and then sine, cosine, and tangent. So in first quadrant, remember y is positive, and our r of a unit circle is always positive. So we have positive over a positive, which is going to equal a positive. In quadrant 2, y values are still positive, r values are always positive, so a positive divided by a positive is a positive. So an angle terminating in second quadrant, the sine of a sine angle will be positive. In our third quadrant, y values of any point in the third quadrant are negative. R, our radius, is always positive, so an angle terminating in third quadrant will have a sign that is negative. In fourth quadrant, y is negative, r is positive, so a negative divided by a positive is always a negative. So again, the sign of an angle terminating in quadrant 4, it will be negative. Now for cosine. Cosine is x over r. So in first quadrant, x's are positive, r is always positive, so a positive divided by a positive is a positive. In quadrant 2, x is negative for any point. R is always positive, so a negative divided by a positive is a negative. In third quadrant, x is negative for any point, and r is always positive, so a negative divided by a positive is a negative. In fourth quadrant, x is positive, r is positive always, so a positive divided by a positive is a positive. Now on to tangent. Tangent is y over x. The y values in the first quadrant are positive. X values in first quadrant are positive. So a positive divided by a positive is positive. In second quadrant, y's are positive, but x's are negative. So a positive divided by a negative is a negative. In third quadrant, y is negative, x's are negative, so a negative divided by a negative is a positive. And in fourth quadrant, y is negative, x is positive, so a negative divided by a positive is a negative, so angles terminating in the fourth quadrant for tangent will be negative. A way to memorize those charts without having to go through doing that every time is the mnemonic all students take calculus. Each word stands for a quadrant and a trig ratio. So there's 4 words, so each like word 1 stands for quadrant 1, word 2 stands for quadrant 2, and so on. So draw your circles. Our first word is all. So first quadrant for first word, and then it's not one of our trig ratios, so it's all of them are positive in the first quadrant. Our second word is students, so second quadrant is what we're looking at. And then which trig function starts with an S, like the word students? Sine. So sine is positive in the second quadrant. Third word, third quadrant, the trig ratio that starts with a T is tangent, so tangent is positive in the third quadrant. Fourth word, fourth quadrant, the trig ratio that starts with a C like calculus is cosine. So in fourth quadrant, cosine is positive. Now that we've exhausted our sentence, everything else that is not marked right now, they are all negative signs. Alright, next bit of information we need is what is called a reference angle. And if we let theta be an angle in standard position, so given in our picture here, our theta is 5 pi over 6, our reference angle is the acute angle theta prime formed by the terminal side of the angle and the horizontal axis. So the angle that we're looking at is this highlighted angle. That is going to be our theta prime. So many times we can just common sense think of this as how far is our angle away from the horizontal axis. And in this case, most of you should be able to answer pi over 6. So our reference angle is pi over 6. If that was a little bit too hard, I have some more examples for you next. Okay, some practice for reference angles. We're going to start with 140 degrees. So you want a circle so that you can sketch your angle onto that circle and put it in the correct quadrant. Then you want to visualize where your reference angle is going to be. So again, remember it goes from the terminal side to the horizontal x-axis. And in this case, our x-axis is at 180 degrees. Okay? So in our head, we want to ask ourselves is how far is 140 away from 180? Mathematically, 180 minus 140, and we get 40 degrees. Next angle is 230 degrees. Sketch the angle. It puts us in third quadrant. Think about where your reference angle is going to be from your terminal side to your horizontal x-axis. That is our yellow highlighted angle. So you want to think how far is 230 away from 180. So 230 minus 180 is going to get us 50 degrees. Next angle is a 300 degree angle. Sketch the angle. Highlight where your reference angle is going to be. Figure out what your horizontal x-axis is worth at that point. So if we went a full rotation around the circle, that horizontal axis would be 360 degrees. So we want to think of how far is 300 away from 360 degrees. And mathematically, we're going to subtract 360 minus 300, and we get 60 degrees. Okay, to summarize our positive degree angles. Okay, if a positive angle is in quadrant 1 or quadrant 2 or 3, our reference angle is 180 minus theta, and then take the absolute value. If a positive angle terminates in quadrant 4, then our reference angle is going to be the absolute value of 360 minus theta. Next, let's try a negative angle. So remember, this angle goes clockwise, so it lands in our third quadrant. Identify your reference angle. Again, we're trying to get to the horizontal axis, which is the x-axis. So we are asking ourselves how far is negative 120 away from our 180. So we are going to take our reference angle is 180 plus a negative 120, which is going to be 60 degrees. Next angle is negative 225 degrees. So again, we are going clockwise, so that puts us into second quadrant. So we want to visualize where our reference angle will be, which is our highlighted angle. We want to ask how far is negative 225 from our horizontal x-axis, which is going to be 180 degrees. So again, we're going to do 180 plus a negative 225 and then our absolute value of that, which is 45. Our last angle is negative 20 degrees. Again, sketch that angle. This is the easiest angle for us to do because it is in fourth quadrant, and since it is going clockwise, all we have to do is think how far away from the x-axis is it? Well, we already know it's 20 degrees, so all we have to do is get rid of the negative sign. So the reference angle for negative 20 degrees is 20 degrees. So to continue our summary down at the bottom down here, if a negative angle is in quadrant 2 or quadrant 3, our reference angle equation can be the absolute value of 180 plus theta. If our angle terminates in quadrant 4, then our reference angle is just the absolute value of theta. Now remember, if we are in radians, it is not 180 and 360, it is pi and 2 pi. So for a positive angle in quadrant 2 or 3, reference angle is going to be absolute value of pi minus theta. A positive angle in quadrant 4 is in radians, then it's going to be our reference angle equals 2 pi minus theta. If we have a negative angle, our reference in quadrant 2 or 3, our reference angle is going to be pi plus theta, absolute value of that. And if our negative angle is in quadrant 4, our reference angle again is just going to be the absolute value. Okay, now to use everything all together to find sine, cosine, and tangent theta of each angle. So let's start with 120 degrees. First thing you have to find is its reference angle. So again, how far is 120 degrees from 180? You should answer 60. Now you are going to find the trigonometric ratios for this angle, our reference angle. So what is sine of 60? Root 3 over 2. You get that from your trig chart. What is cosine of 60? 1/2. What is tangent of 60? Root 3. Now we're going to pull together all the things that we've learned in this unit, and we need to decide the signs for the trig ratios for our original theta. So we need our sine charts, starting with drawing our angle on, so we know what quadrant it is in on our sine charts. Doing sine of 120, we need our sine of 60, which is root 3 over 2, and we need the sign that is in the quadrant of our terminating side of our angle. So for sine, that is positive. So sine of 120 is going to combine these two things, so it is positive root 3 over 2. Cosine of 120, we are going to combine the answers of cosine of 60 and our sine in our second quadrant for cosine. Okay? So cosine of 120 is going to equal negative 1/2. Tangent of 120, we need to combine our tangent of 60 and our sine in our second quadrant for tangent. So we're going to get negative and root 3. On to practice a angle that is in radians. We're going to do 5 pi over 4. Again, since we have our circles up, let's go ahead and draw that angle on. We want its reference angle. The reference angle for 5 pi over 4, how far away is it from pi? It is pi over 4 away. Next, we're going to find the trig ratios for pi over 4. So find sine of pi over 4, which is root 2 over 2. Find cosine of pi over 4, which is root 2 over 2. Find tangent of pi over 4, which is 1. Sorry about that. Okay, now Decide the signs for the trig ratios. This again is going to pull together our answers from that step and our signs on our sign chart. So sine of 5 pi over 4, we need the answer of sine of pi over 4 and the sign in third quadrant of our sign chart. Okay, so sine is negative in third quadrant and sine of pi over 4 is root 2 over 2. So sine of 5 pi over 4 is negative root 2 over 2. Cosine of 5 pi over 4, again we're going to pull together our two parts. Cosine of pi over 4 is root 2 over 2. Cosine in third quadrant is negative. So cosine of 5 pi over 4 is going to be negative root 2 over 2. Tangent of 5 pi over 4, we're going to pull together our two parts again. Tangent of pi over 4 is 1. Tangent in third quadrant is positive. So pull those together. Tangent of 5 pi over 4 is positive 1. Our essential question is, what is a reference angle again? Because as you can see, our reference angles play a very big feature in being able to find these angles. So it's an acute angle formed by the terminal side of the angle and the horizontal axis. Your homework is out of chapter 6.3 in your book, page 484, 1 through 23 odd, 29 through 67 odd.